High Voltage takes center stage in this brand new season of Hitachi Energy's Power Pulse podcast. We promise to bring you great content from the brightest minds in the business. We'll discuss challenges, opportunities, and all the hot topics any high voltage enthusiast, or anyone interested in sustainability for that matter, is sure to enjoy. This episode of the podcast is all about the ins and outs of a high voltage factory, what it takes to run it, the experts we need in our teams, what happens in there, and how we make sure that all our staff are safe in that environment and able to produce equipment that is also safe and reliable for our customers. To tell you about it, we invited Claire Carmona, who runs the GIS factory in Zurich. In addition to experience on the job, she also holds a master's degree in management technology and economics from ETH Zurich and another master's in mechanical engineering from Central Paris.
Welcome back to Power Pulse. I'm your host, Sam Dash, and today I'm speaking with Claire Carmona, the operating unit manager for gas-insulated switchgear. Hi, Claire.
Hi, Sam.
Thanks for joining us today. In doing my research about you, one thing I learned of particular interest is that you've done a 2-week backpacking trip through Patagonia. Is that right?
Yeah, that's right.
Can you tell me a little bit about that experience?
Yeah, well, actually, it was my honeymoon trip.
Oh,
and
wow.
We decided to really go in the unknown. We are both mountains lovers.
Uh-huh.
And we basically took all our stuff for 2 weeks in the backpack, and we went from cabana to another cabana in Patagonia, enjoying the beautiful landscape that is there. We were very lucky in meeting a lot of different people that was on the road, sometimes just crossing paths and sometimes following the same path.
And so I can imagine with, all the different paths and maps involved, etc. Did it take quite a bit of planning to do that trip, or did you sort of play it by ear?
No, I planned it actually from Switzerland, so I had reserved everything before.
Yeah.
Because there is a limited place to sleep up in the mountains.
Yeah.
Also, there was a lot of bus traveling that needs to be booked in advance. So we had planned it all through before.
Yeah, various challenges sort of logistically, and I'm sure in terms of the environment and the climate too. Is that right?
Yes, we were lucky to have very good weather. Patagonia can be also very windy, and we went there in January and had a fantastic good weather.
Oh, lovely. I'm jealous. So, Claire, I wonder if you could paint the picture for us. We're driving up to the high voltage factory. We go inside, and what do we see? How many people work there? Do they wear special safety gear? What kind of equipment is visible?
So maybe the first thing that can be a little bit surprising is that it is not a factory where, we are grinding or milling or something. We have nothing dirty in there.
Right.
So it is a very bright, clean and colorful factory.
It's sort of not the factories that you imagine from like the Industrial Revolution.
Exactly.
Yeah.
Exactly. What we do in Zurich is really the final assembly of a gas-insulated switchgear and then the testing. So what you have is you have cranes, you have production lines where you see really the GIS being assembled step by step until it becomes or a complete module or a complete bay that is ready to be tested in our test facility.
So you mentioned the bays. How are those huge bays of switchgear put together? How big is a bay, comparatively speaking? Is it the size of a car, a truck, a train?
Yeah, so you can say it's higher than a car. It can be 2 meters, 2.5 meters. Mm-hmm. And it's larger than a car, or maybe as large as a big car.
Yeah. Right?
And this bay, we assemble full bays for everything that is up to 400 kV. Or for the big ones, we assemble only the components here. Then we deliver them on site, and on site they will be put together.
Amazing.
Right, so we have the two possibilities.
And then, so if you're putting them together here, what's that process like?
Mm-hmm. So typically we have a platform where we will build the bay on it, and it's with a steel structure. And then we start building the element on it, so step by step. So we have the circuit breaker, which is, of course, let's say the core element, the heart of it. And then we build the components around it, earthing switch, disconnector, CTs, any connection elements.
And how long does that process generally take to build that bay?
Yeah. So typically it takes, let's say, 1 or 2 weeks if everything runs smooth.
Yeah. Yeah, and fingers crossed, I assume.
You asked, let's say, how do the people look like, right? So
the people who work in the factory and yeah.
So we have the people on the shop floor that are obviously wearing, let's say, Hitachi Energy clothes,
uniforms, etc.
with safety shoes. But what is also a little bit special about our factory is that they are wearing a hairnet to avoid that the hair is falling into the equipment. and could, let's say, bring PD signal, partial discharge signal in our GIS.
That term, can you say that again for us? I don't recognize that term.
Partial discharge?
Yeah.
It's when you have particles in a high voltage equipment, and then the electricity goes to the particle and not along the conductor as it should be, and therefore this is not something we want in our material.
Right. So if I understand correctly, you want to avoid any particle, sort of crazy to wrap your head around because particles are so small, but you want to avoid any particle from interfering with that electric current. So your workers who work in those factories are wearing hairnets similar to people who might work in a factory that deals with food or
semiconductors, right? Something similar. Yeah.
Right. So the same sort of thought is going into the manufacturing of these components and this equipment as would go into producing food that we eat.
Yes. Yeah. And we also have air supply with overpressure in the factory to make sure that the dust is being kept outside as much as possible.
I assume that's for both the safety of the workers as well as the safety of the equipment. Is that right?
That's really for the quality of the equipment.
Yeah. And there are other safety controls put in place for the people who work there, I assume, as well.
Right. So we are following the same global rules in all the factories in Hitachi Energy, right? So we have the 10 life-saving rules that we are following. I can give you an example. Is, for instance, let's say I'm not below a suspended load, right? Or before I start to work, I do a stop 5 and I look at the risk of the work, right? Yeah. So we have 10 principles like that we want to follow. And for everything that is electrical works, we have also 7 electrical steps that we have to follow in every work we do.
Yeah. So a lot of thought goes into the whole process. Now, I wonder, how are the finished products put together? So for instance, in Zurich, where you manufacture the gas-insulated switchgear, or GIS, as you were saying earlier, what are the basic steps from start to finish?
So you have to imagine that we get half of them from our feeder factories, so our internal suppliers. And the rest of the components we get from external suppliers. So all this is being delivered when we want to start with the production of a bay. Then there are some elements where we do the pre-assembly in Zurich. So for instance, today we do pre-assembly of CTs for the subtransmission line, for instance. Then we do this pre-assembly so that we have complete modules ready to be mounted together. And then we have this platform where we start with a steel structure, and then we start putting like a Lego really the elements together. The elements are quite big, right? You cannot carry them by hand, right? So we have cranes to carry the elements and mount them on the platform and then assemble them one to each other.
But that's a great analogy you sort of bring up there, which is that you're sort of fitting these things together like Lego blocks. So they all have a particular way of fitting together, and you have to make sure you're getting that connection as seamless as possible. Is that right?
Exactly, yeah. So you need to make sure it's well centered. Then you need to make sure you're screwing the bolts correctly, right? And this is until you have the bay ready. In the case we produce a full bay. And then the big part of our work is the testing, right? So this bay is then going through the testing. So we are testing if the bay is tight. So if we have no gas getting out. So we fill it with gas, we test the tightness, and then we release it. We test mechanical testing, right? So if the operating mechanism is acting well and really opening the breaker as it should and as quick as it should. And finally, we do the HV test, so high voltage testing, to really check that our bay is ready to perform also on a high voltage.
Right, that it's ready for showtime. So how long does that process actually take from start to finish of the materials arriving on site and then the GIS finishing with its testing?
Mm-hmm. So it can depend, I would say, something between 2 to 5 weeks.
That seems very quick. Has it taken that long in the past, or is it taking sort of a shorter amount of time year by year? Is the system getting tighter and tighter?
That's the target, right? Yeah. Obviously, to reduce the time. Currently, what we are focusing on is on removing the disruptions that prevent us to produce in this time. We have, let's say, disruption in terms of material availability or in quality problems, and this is our focus so that we can start having a running flow.
If you were to say the top disruption or the biggest or most common disruption these days that you're up against, what would that be?
So it is really material availability.
Yeah.
That's the top one. so where we have a material missing. And the second one are quality problems.
Yeah.
So we have, for instance, a leakage during the cast testing, and we need to find out where this leakage is coming from and solve it.
And you sort of touched on this already, but what sort of jobs are done in these factories? Who are the different people that are working on these products?
Mm-hmm. First, I would like to say in the factory, we don't have only the shop floor, right? So we have all type of functions, starting from sales, project management, engineering, continuous improvement. We have planning, we have logistics, we have quality engineering, right? And of course, then we have the production. So we have in total 450 people with 45 different nationalities.
Wow.
And the different jobs we have can be as diverse as, let's say, fitters. We can have automation engineer. We can have, let's say, HV, high voltage specialist. We have mechanical and electrical engineer. We have continuous improvement specialist. We have also a lot of business administration people. So we have really a diverse population of employees, both in nationalities and also in the type of backgrounds they have.
Are those factories primarily in Switzerland or in Europe or Asia? Where are the factories?
Yeah. So we are organized in a network of factories globally. We have two types of factories. We have the operating unit, like Switzerland, that are facing the end customer and doing the final testing, final assembly. There you have such a factory in Zurich, in Switzerland, in Saudi Arabia, in China, and in India. And then we have the feeder factories. Feeder factories are our internal suppliers.
Right.
They are in Bulgaria, they are in Czech Republic, they are also in India, they are in Vietnam, and also in China.
Do the factories that produce the exact same thing operate differently at all, depending on where in the world that factory is? Like, are there safety rules that are followed no matter where you are in the world, but are there also circumstances that are very particular to a certain location?
So I think the vision is that every factory is operating in the same way, right? And is building the same products, that we are really standardizing the product platform that we are working on. Now, different factories serve different markets, and different markets are acting differently, right? So we have certain factories which serve a market which is very standardized. So they will typically have a standard base going through their factory. While we have in Zurich a diversity of customers, we serve mostly Europe and the US. So we have a diversity of customers with a lot of requirements. So we don't have one single bay looking the same than the other.
Right. Is that both because of the requirements of the customer, but also government regulations?
Can be government regulations. Mostly it is really about customer technical requirements.
Right. Now, I've heard of the concept of lean manufacturing. Can you tell our listeners, and me for that matter, what lean manufacturing is?
So lean manufacturing is really when you get the material on time and you produce just in time for the customer. Not too early, not too late, but just really when the customer requires it. Then you have a flow production where any disruption is making very visible and is tackled in a very agile way. Then you tackle waste in the operations in a very consistent way with continuous improvement.
Correct me if I'm wrong. This sounds like a positive thing, lean manufacturing. Is this something that you work towards at Hitachi Energy?
Yes, definitely. So lean manufacturing is really who we want to be. And currently with the extraordinary demand that we have from the market, we are working at nothing else than trying to stay lean, right?
Yeah, terrific. So you're currently implementing the new SF6 free Iconic portfolio. Can you tell us a bit more about what this means concretely for the factory? What does that look like to be using a very different ingredient in production?
Yeah. Thank you for the question. And this is actually something I like a lot about working in a production is everything is visible, right? You can really see it, you can touch it.
It's tangible.
It's very tangible.
Yeah.
So for Iconic, and this is really, let's say, our first priority, this is our purpose to produce this Iconic portfolio. It's very visible in the factory because we have, I like to say we have two cardiovascular systems now. We have an orange one, which is, let's say, bringing SF6 gas, current gas, to the lines, to the different lines, and where we can fill the equipment with, right? And we have now installed everywhere also a green cardiovascular system, which is bringing our new mixture to the different lines so that we can fill our Iconic products with it. We also had to install tanks in the factory where we are pre-mixing the gas we need. You have to understand that so far SF6 was not a mix, it was a single gas. Whereas, let's say, for Econic, we use a mixture of 3 different gases. So this mixture is happening in the factory in big tanks that is then feeding the different lines in this green cardiovascular system.
So let me make sure I'm getting this right. So SF6 in the past has been sent to the factories already pre-mixed.
No, SF6 is only one gas. You don't need to mix anything.
I see. One gas made up of a few different chemicals, but you're mixing on site the new gas, which is Econic.
Yes.
And so I love that image that you've painted for us, those cardiovascular systems, and sort of one system that's bringing in this new component and one that's been delivering the older one. Bringing us to how these factories are operating, how do you monitor what raw products and materials come into the factories? What processes or software do you use, or where are you headed with innovation around that?
So first we have SAP, which is our backbone system, where we receive our material in SAP. And this is where we handle all our customer projects in SAP. And then in the production, we have an MES system, which is a manufacturing system, which is linked to our new digital passport system. And the digital passport system is really a way to trace all the materials we have, the main components, back to the suppliers. That's really powerful because in case we have any problem, for instance, on site at the customer, we can trace it back to, okay, that part has been produced at that supplier. You're in that batch, right? So we can check maybe the other parts of the same batch. The target is really to increase quality, to increase transparency, with having this traceability along the whole value chain from our external, internal suppliers up to the customer.
Amazing. Let me ask you this also. What advice would you give a young person wanting to get into the same line of work as you?
Well, I think a factory is a wonderful place to start working. You will learn really the basics about, let's say, operational processes. You have so many different jobs that you can never get bored. And once you figure out how a factory works, right? I mean, that's really then a lot of different works are possible.
Fantastic. Thanks so much for joining us today, Claire.
Thank you very much, Sam, for having me.
You've given us a really detailed look into the nuts and bolts of how high voltage products are made. Thanks for tuning in to this episode of Power Pulse. Until next time.
And that's it for today. We'll be back soon with some more great content. But before you go, remember to give us a follow so you don't miss an episode. Thanks for tuning in. See you soon. This episode was brought to you by Hitachi Energy. Created and introduced by Barbara Freitas-Daniels. Content and script writing by Cassandra Inay. Guest speaker Claire Carmona. Hosted by Sam Dash. Produced and edited by Creative Chimps.